If you have ever tried to wire a language model into a real program, you have probably hit this exact wall. You ask it a simple question, you want back a clean little piece of data you can actually use, and instead it hands you a friendly paragraph. Sure, here is the information you asked for, it says, and then it buries the one number you needed inside 3 sentences of chit-chat. That is fine if a human is reading it, it is a disaster if a program is. The program does not want a nice paragraph. It wants a value in a known shape every single time. So today I want to walk you through how I actually get clean, structured data out of a model, the methods that hold up when this is running unattended, and the parts that still go wrong even when you do everything right. Why prose is the enemy of a pipeline? Let me explain why this matters so much. When you talk to a model in a chat window, prose is great. It is friendly, it is readable, you are a person and you can just read it. But the second a model sits inside a pipeline, feeding its answer into the next step, that friendly prose becomes the single most fragile part of the whole system. The next step needs to pull out a field. Maybe it is a price, maybe a category, maybe a yes or no. And now you are writing fragile little string searches to fish that value out of a sentence that the model is free to phrase 100 different ways. One day it says the price is $12. The next day it says that will run you about 12 bucks. Your search breaks and you do not even find out until something downstream quietly does the wrong thing. The format itself has become a moving target. What you actually want is a contract. You want to say, give me your answer in this exact shape with these exact field names and nothing else. No greeting, no explanation, no trailing have a nice day, just the data. And the good news is there are real ways to get that, but most people reach for the worst one first. The lazy way and why it fails. The lazy way, the one everybody tries first, is to just ask nicely. You write a prompt that says, please respond only with JSON, do not add any other text, and you cross your fingers. And honestly, with a good model, this works most of the time. That is exactly what makes it so dangerous. It works in your testing, it works in the demo, and then it ships. And then one day, on some input you never tried, the model decides to be helpful and wraps your JSON in a little code fence, or adds a sentence before it explaining what it did. Your parser chokes on that extra text and the whole job falls over. Most of the time is a death sentence in a system that runs thousands of times. If a thing works 99 times out of 100, and it runs 1,000 times a day, that is 10 failures every single day, quietly. So asking nicely is a fine starting point, but you can never trust it on its own. You need something that does not depend on the model being in a good mood. And the really insidious thing about this failure is the timing. It does not break when you are watching. It breaks weeks later, on a Friday, on some oddly shaped input a real user sent, when you have long since moved on and stopped thinking about it. By then, the cause is buried under a pile of other code, and you spend an afternoon hunting a bug that turns out to be one stray sentence the model felt like adding. I have lost that afternoon more than once, and it is what finally taught me to never let the format depend on good behavior. Ask for a schema, not a vibe. The first real upgrade is to stop describing what you want in words and start handing the model an actual schema. A schema is just a precise description of the shape you expect. This field is text, this one is a number, this one can only be one of these 3 values, and these fields are required. Instead of writing, please give me the product name and the price in a paragraph of instructions, you give it a structure. Think of it like the difference between telling a contractor, make me a nice form, and handing them the actual form with the boxes already drawn. You are not hoping they guess your intent. You are giving them the outline to fill in. A clear schema does 2 things at once. It tells the model exactly what you want, in a language that leaves very little room for creativity. And it gives you something to check the answer against later, which is going to matter a lot in a minute. When I set one of these up, I spent most of my time on the schema, not the prompt. The prompt just points at the schema and says fill this in. And there is a quiet bonus to working this way. The schema becomes the documentation. 6 months later, when I have forgotten how a piece of this works, I do not have to reread a fuzzy paragraph of instructions and guess what I meant. I read the schema and it tells me exactly what this step produces in black and white. The shape of the data is the clearest description of what the step is even for. A vague prompt rots over time. A precise schema stays true because the code downstream depends on it and would break the moment it drifted. The real fix is constrained decoding. Here is the part that actually changed things for me, and it is the piece most tutorials skip. The strongest way to get structured output is to not let the model produce anything else in the first place. This goes by a few names. You will hear JSON mode, or structured output, or constrained decoding. The idea underneath all of them is the same. Instead of letting the model pick any word it likes at each step and hoping the words add up to valid JSON, the system actively restricts its choices so that only output matching your shape is even possible. It physically cannot add a greeting because a greeting is not a valid next step in the structure. It cannot forget a closing bracket because the structure will not let it stop there. A lot of providers and a lot of local tools support some version of this now, and when they do, you should use it. It is the difference between politely asking someone to color inside the lines and handing them a stencil. The failure mode, where the model just wraps everything in chatty text, basically disappears because there is no room left for chatter. This is not magic, and I want to be careful here. The model can still put the wrong value in the right box. It can still be confidently wrong about the actual content, but at least now the shape is guaranteed, and that is a huge amount of fragility gone. Validate everything you get back. Even with all of that, I never ever trust the output blindly. The next step in my pipeline is always validation. I take whatever the model handed back and I check it against that same schema in code before anything else is allowed to touch it. Is the price actually a number? Or is it the word 12 spelled out? Is the category one of the values I said it had to be? Or did the model invent a new one? Are all the required fields actually present? Or is one quietly missing? This validation step is cheap to write, and it pays for itself the first time it catches something, and it will catch something. The model is good, but it is not perfect, and the whole point of building a system is that it keeps working when the pieces inside it misbehave. I think of the model as a fast, clever assistant who occasionally hands me a form with one box filled in wrong. I would never feed that form straight into the rest of the machine without a quick look. The validation is that quick look, except it happens every time, automatically, and it never gets tired or distracted. Handle the failures that still slip through. So what happens when validation fails? Because it will. You have a few honest options, and I use all of them depending on how much the answer matters. The simplest is to just try again. Models are a little random, so the same request a second time often comes back clean. The next step up is to repair the answer. You hand the broken output back to the model and say, "This did not match the shape. Here is what was wrong. Fix it." That second pass succeeds surprisingly often, because pointing at the specific mistake is a much easier task than getting it perfect the first time. And the last resort, the one that actually saves you, is a fallback. When an answer fails too many times, you do not just crash or, worse, pass garbage downstream. You flag that one record for a human to look at, and you let the rest of the batch keep moving. The goal is never a system that never fails. The goal is a system that fails in a small, contained, visible way, instead of silently corrupting 1,000 rows because one of them was malformed. Let me show you a real example. Let me make this concrete with something I actually do. Say I have a pile of messy invoices in all sorts of layouts, and I want to pull a few fields out of each one. The vendor name, the total, the date, and a list of line items. The old way to do this was brittle templates and a lot of swearing. The new way is, I define a schema with exactly those fields, I turn on the structured output mode, and I feed the model the raw text from each invoice one at a time. Back comes a clean object, the same shape every time, no matter how wild the original layout was. Then my validator checks it. The total has to be a number. The date has to look like a date. The vendor cannot be empty. Anything that passes flows straight into my records. Anything that fails gets set aside for me to glance at by hand, which is usually 2 or 3 oddballs out of a few hundred. The result is that the boring, error-prone job of reading invoices became a quiet background process, and I only spend my attention on the genuine edge cases that actually need a human eye. Let me be honest about the limits. Now the honest part, because I am not here to sell you a fantasy. Structured output makes the shape reliable. It does not make the content true. The model can hand you a perfectly formed object where the total is just wrong because it misread the invoice. The structure being valid does not mean the answer is correct, and confusing those two things is how people get burned. You still need to sanity check the actual values for anything that matters. Constrained decoding also costs you a little. It can be slightly slower, and on some setups it is not supported at all, so you fall back to asking nicely plus heavy validation, and complicated, deeply nested schemas can confuse the model just like they confuse a person. So I keep my shapes as flat and as simple as the job allows. None of this is a reason to skip structured output. It is just the difference between using it with your eyes open and trusting it like a magic box, and I would always rather you used it with your eyes open. So who actually needs this? So should you bother with any of this? If you are just chatting with a model in a window, no, you do not need a schema for that. Just talk to it. But the moment a model's answer is going to feed a program instead of a person's, structured output stops being optional. It is the thing that turns a clever demo into something you can actually leave running. The order I would learn it in is simple. Start by asking nicely so you understand the problem. Then add a real schema so your intent is precise. Then turn on constraint decoding wherever your tools support it, so the shape is guaranteed. And always validate what comes back, because the model will eventually surprise you and you want to find out in code, not in production. Get those 4 habits down and you can wire a model into almost anything without lying awake wondering what it is quietly mangling tonight. That is the whole picture, from a chatty paragraph you cannot use to clean data you can actually trust in a pipeline. I am going to keep breaking down the unglamorous plumbing that makes AI actually usable in real systems. The parts the flashy demos always skip. If that is your kind of thing, subscribe and follow along, because there is a lot more coming. Thanks for watching, and I will see you in the next one.